Hi again, class. So, we have been talking so far about static electricity. This is basically the electricity that is generated as a result of charges that are not moving, that basically are static. Okay, they're at rest. And we've been talking about how static electricity is created by different methods of charging. For example, charging by contact, charging by friction, charging by induction. And we also have been talking about different types of materials and how the materials themselves are what enable different types of charges to take place. So all matter is made up, as you know, of atoms, and atoms are made up of subatomic particles known as electrons, protons, and neutrons. And it's the electrons and the protons that allow for these charges basically to happen in the first place. Okay, so we know that electrons are the particles that are able to move, okay, from one material to the next. And some materials are more readily, or some materials allow for this movement more readily than others. And these materials that allow for these free moving electrons are known as conductors, and the materials that don't allow for electrons to move freely are insulators. And when we were talking about static electricity and the electrostatic series, for example, that list of all those materials that have an increasing hold onto their electrons, we're talking about insulating materials. So we are going to start talking about electric current and current or current electricity. And this is the type of electricity that involves the movement or the flow of electrons. And therefore will require a different type of material, because moving electrons require their atoms to allow for a movement from the valence level. So let's begin. So what is electric current? Where is it found and how is it measured? So these are the goals of the lesson today. So we're going to define electric current. We're going to talk about a little bit about electric circuit, even though we're going to talk about that more later. The difference between AC and DC, identifying and describing different quantities that can be measured in electric circuits, and we'll talk about those in more detail in following lessons. So let's recap a little bit about what we know already, or hopefully what we know already. So we know that atoms have electrons in their valence shells. Okay, we know that. And and these basically electrons are the ones that are involved in those chemical reactions. Okay, these are the electrons that can either be transferred or shared. Well, we know we can also know that, or we also know that these electrons, these free electrons, can move from atom to atom depending on, though, the material of which the atoms, or the material that's composed of those particular types of atoms. So insulators, again, they limit the movement of electrons, holding on to them tightly. So glass, plastic, wood, wool, all those things that you saw, materials on the electrostatic series, were examples of insulators, and some of them have a stronger hold on their electrons than others. Okay, And so these are not going to allow electrons to move freely. Whereas conducting materials or conductors are materials in which they allow the electrons to move freely. And again, depending on the type of conductor, the type of conducting material, those electrons are going to move more or less freely. For example, copper and gold are examples of conductors. Copper is an excellent conductor of electrons, and that's why wires made or used are used for electrical circuits. For all types of electrical wiring, use copper because of the fact that it allows electrons to move freely, but it is also very, very flexible. So it's malleable and ductile and allows for a perfect, it provides for a perfect material in which to make electrical circuits out of, okay? So static electricity is where the charges are at rest. So electrons are not moving, and this next section of the electricity unit is based on current electricity, which is basically where the electrons are moving inside a conducting material. So here you have a diagram showing this is just a sample of a conducting material, and you see that some of those electrons are in the valence shells and in the other shells in the inside. This is the nucleus of the atom. These are these are basically atoms of that conducting material. And then you see these free electrons that are basically going to move from one atom to the next and back and forth. And in no fixed pattern. They're just randomly moving back and forth. In an insulating material, however, there are no very, very few free electrons. They're all kind of fixed in a fixed position and orbiting that the nucleus of that atom. So that's the difference between an insulating material and a conducting material, the free flowing electrons. So the electric current definition, basically it's just the flow of electric charge through a conductor in a closed path. So any type of conducting material within a closed path, and we'll talk about what a closed path is, okay? There are two types of electric current that we talk about. There is what is known as direct current, also known as DC for short, and alternating current, which is AC for short. So direct current is the current, an electric current, or the flow of charge in which the electrons will flow only in one direction. So usually the electrons will flow from a negative, these two are symbols, and we're going to talk about symbols. This is a very simplified electric circuit. I'm sure you've all seen these types of circuit diagrams before. We're going to review those circuit symbols in additional lessons. But this is a symbol of a battery with two cells. This is a symbol of a cell. This is also another symbol of a cell. When you have more than one cell in an electric circuit, it is considered a battery. So this whole thing with two cells is a battery. And this is the negative terminal of the battery, and this is the longer stick right here, or line, represents the positive terminal of the battery. And so the electrons are going to flow from the negative terminal all the way around the conducting material, the conducting wires, along a path, and will move to the positively charged terminal of that battery. Okay, and this is allowing for only one direction. So direct current is used in very simple simple circuits that are powered by energy cells or batteries. Okay, this is the one. This is basically direct current is used for very simple gadgets, electrical gadgets like a flashlight or a watch. Anything that uses kind of like cells or batteries, they use direct current. Electrons moving in only one direction. Alternating current is the other type of current, and this is where the electrons, are going to change direction. So they will move in one direction, and then they can switch to move in the opposite direction. Electrons in an alternating current circuit can reverse direction up to 60 times a second. So that's really, really a lot of kind of back and forth in a very short amount of time. This type of current is used to power our homes, for example. So the electrical energy distribution grid, okay, so Hydro Canada, Hydro Ontario, for example, uses an alternating current. In all homes and buildings, etc. They're powered, everything's powered by alternating current. So this is a very complex use of electrical energy compared to the simpler circuits that use the direct current. So this is just a diagram showing you direct current where the electrons are moving in one direction. In this case, this is the electrons are moving from the positive terminal around to the negative terminal. And this is alternating current showing you that it's going in both directions. Okay, and it's going to keep on changing alternative current. Okay, and we'll talk about what these resistors mean in another lesson. So when we measure charge, okay, there's a lot of terminology that you're going to learn within the next few lessons, and it might get confusing, but I'm going to try and simplify it as much as I can. So the charge on an electron, okay, when we're measuring electric current, so let's go back to that definition again. It's the flow of electric charge, which is basically the flow of electrons. So when we're looking at, when we're talking about the charge of an electron, we can't just talk about the charge of a single electron, because that unit would be way too small for everyday use. We can't use, that wouldn't make any sense. So a French physicist known as Charles Augustin de Coulomb basically came up with this idea of coulombs of charge. And so the coulomb is used instead as a unit of measure for charge, and it is represented by this capital C. And so the amount of charge passing by a point within a circuit is equal to 1 coulomb. Okay, and basically 1 coulomb is going to be equal to 6.25 times 10 to the power of 18 electrons. That's a lot of electrons. So the amount of charge passing by any point in an electrical circuit is equal to 1 coulomb, which is 1 coulomb is equal to this many electrons flowing through that circuit at any one point of time. Electric current, again, is the rate of flow of charge, and basically the quantity of charge that flows per second. Electric current is measured in what are known as amperes. and the symbol for amperes is capital A. And we can simplify this term amperes, and I'm sure you've heard of this term before. The short version of the amperes is called amps. Okay, and the device that's used to measure electric current in a circuit is called an ammeter. So the ammeter is measures current in amps. And 1 ampere, okay, which is represented by 1 capital A, is equivalent to 1 coulomb per second. Okay, so remember 1 coulomb is equal to 6.25 times 10 to the power of 18 electrons. That's basically representing that many electrons. And 1 ampere is that many electrons in a circuit per second. Okay, so it's 1 coulomb per second is equivalent to 1 amps. So when a charge of 1 coulomb flows past a point in 1 second, the current is considered to be 1 coulomb per second. So that many electrons, so let's go back, that many electrons, these flowing past in 1 second is considered 1 amp. Okay, and the measuring charge, so current, again, we're repeating this again, it's the rate of flow of charge, it's the rate of the flow of the electrons, basically, is represented by this formula, where I is equal to, again, current, okay, electric current, and this triangle, as you all should know, means delta, or change in. So the current is equal to the charge that flows over delta T, which is the change in time, which is equal to coulombs per second. And the unit of measure that we use to represent current is going to be those amperes or amps. Okay, so that is basically how we measure charge, and that's how we will be doing certain calculations later on after we learn about how to draw electrical circuits and read electrical circuits. We need to figure out how to what causes those electrons to, let me go over back to these diagrams, what causes those electrons to move faster, what slows them down, why do they go either from negative terminal, how do they go from the negative terminal to the positive terminal, and vice versa. And that's what we're going to be looking at in the next series of lessons. So I'm going to leave you today to try and process all this information. I'm also going to add there's 2 more slides to this, and I'm going to talk about those at a different time. So just try and ignore them if you want for now. But I will be adding maybe a YouTube video to kind of go over this information as well. And you will be getting a reading and some questions to go over using your textbook. And we will continue with electric circuits in the next lesson. Take care and hope you have a wonderful day.